Multi-cloud is not a strategy, it's a reality. 84% of enterprises run workloads on 2 or more cloud providers in 2026. The average enterprise cloud estate spans AWS at 47%, GCP at 31%, and Azure at 22%. Each provider has different pricing models, instance types, networking architectures, IAM systems, and service offerings. Human cloud architects can optimize within one provider. Nobody can manually optimize across 3 providers simultaneously while accounting for cost, performance, latency, compliance, and resilience. AI decision engines exist specifically to solve this impossible optimization problem. AI decision engines continuously ingest 3 data streams: workload metrics, CPU, memory, latency, throughput, error rates for every service across every cloud. Cloud pricing, real-time pricing for every instance type, storage tier, and network egress path across all providers, updated hourly. Policy constraints, data residency requirements, compliance mandates, latency SLAs, budget caps, and team preferences. The engine runs optimization algorithms every 15 minutes, generating decisions for workload placement, autoscaling parameters, traffic routing, and cost allocation. Decisions execute automatically within policy guardrails, or queue for human approval when they exceed impact thresholds. Workload placement is the highest impact decision. Not every workload belongs on every cloud. Batch processing that's 43% cheaper on GCP preemptible VMs should run there. Latency-sensitive APIs that need to be within 5 milliseconds of your AWS-hosted database should stay on AWS. Windows workloads with Active Directory integration belong on Azure. The AI engine analyzes each workload's requirements, compute profile, data locality, network patterns, compliance needs, and recommends optimal placement. One media company replaced 34 workloads based on AI recommendations and saved $287,000 annually without any performance degradation. 3 workloads actually performed better after migration because they landed on instance types better suited to their compute profile. Cross-cloud traffic optimization reduces latency and cost simultaneously. When your service runs on AWS East 1, GCP Central 1, and Azure Eastus, the decision engine routes each user request to the nearest healthy endpoint based on real-time latency measurements. During an AWS East 1 degradation, traffic automatically shifts to GCP and Azure endpoints within seconds, not the minutes or hours a human operator would need. Egress cost optimization routes inter-service communication through the cheapest path, often keeping traffic within the same cloud provider's network instead of crossing provider boundaries. One global SaaS company reduced P99 latency by 34% and network costs by 28% through AI-optimized traffic routing. Cloud diversity provides resilience that single cloud architectures can't match. When an AWS region experienced a partial outage last quarter, companies with AI orchestration across clouds maintained full service availability. The decision engine detected elevated error rates and latency from the affected region within 30 seconds. It redirected traffic to healthy endpoints on GCP and Azure, scaled capacity on those providers to handle the shifted load, and monitored recovery. Total customer impact, 0. Companies running single cloud with manual failover took an average of 47 minutes to fully recover. Multi-cloud with AI orchestration isn't just about cost optimization, it's about surviving the outages that will happen. Cost arbitrage is continuous, not quarterly. Cloud pricing changes constantly, spot prices fluctuate hourly, reserved instance markets shift, new instance families launch with better price-performance ratios. AI engines exploit these changes automatically. Batch workloads run on whichever provider offers the cheapest spot capacity right now. Development environments spin up on the provider with the lowest on-demand pricing for the required instance type. Storage tiers automatically migrate data between hot, warm, and cold storage based on access patterns, regardless of which cloud hosts the data. One data analytics company saved 51% on compute costs by letting the AI engine route batch jobs to the cheapest available provider every hour instead of statically assigning them to AWS. Autonomous multi-cloud decisions require strict policy guardrails. Data residency, HIPAA workloads stay in U.S. regions on approved providers. PCI workloads run on dedicated instances with encryption at rest and in transit. EU customer data never leaves EU regions. The engine enforces this regardless of cost optimization opportunities. Budget caps: no team exceeds $50,000 per month without approval, enforced across all three providers simultaneously. Approved provider lists: some teams are authorized for AWS and GCP but not Azure due to enterprise agreements. Change impact thresholds: workload migrations affecting more than 100 users require human approval. These guardrails mean the engine optimizes freely within safe boundaries and escalates edge cases to humans. Unified visibility is what makes multi-cloud manageable for humans. One dashboard showing total spend across AWS, GCP, and Azure, broken down by team, service, and environment. Resource inventory across all providers with utilization metrics. Alert aggregation: not three separate alerting systems, one unified view with intelligent deduplication. Optimization recommendations ranked by savings impact. Cost anomaly detection across providers, catching the GCP project that started running GPU instances at 3 a.m. because someone forgot to terminate an ML experiment. One pane of glass replacing 3 cloud consoles, 3 billing dashboards, and 3 monitoring systems. Platform teams report this unified view alone saves 10 hours per week previously spent switching between provider consoles. Start with 3 steps. Connect all cloud accounts in read-only mode. The engine needs billing data, resource inventories, and metrics from every provider. Run analysis for 30 days without making changes, build the optimization model, identify placement opportunities, and establish baselines. Enable optimization on non-production workloads first. Dev and staging environments are safe testing grounds for placement changes. Measure cost and performance impact for 2 weeks. Then gradually enable production optimization with full policy guardrails. Most teams see first savings within 14 days of enabling non-production optimization. Production savings follow within 30 to 60 days. Multi-cloud is your reality whether you planned it or not. AI decision engines turn that complexity from a liability into an advantage, optimizing cost, performance, and resilience across every provider simultaneously. Connect your cloud accounts in read-only mode this week and see what the analysis reveals. I'm AI DevOps Daily. Next episode: Observability 2.0, an AI that fixes problems before you know they exist.